Hello everyone, Miss Meek here. Today we are going to talk about side relationships and triangles. Side relationships in triangles. And so what's going to happen is we're going to know one or two sides of the triangle and we're going to have to find the third side. Now, this is not just going to be guess a random number and hope it works. We're actually going to talk about two specific types of triangles, isosceles triangles and equilateral triangles, and how we can use what we know about the sides of those triangles to find a missing piece or a missing side of that triangle. So let's go ahead and jump in and look at isosceles triangles. Now, if you remember, isosceles triangles have two equal sides. And remember, the way that I show what sides are equal are these little tick marks of congruency. Okay, so those little tick marks right there show which two sides are equal. So I can see that this side here, which when triangles have letters on them, it gives them a name. So for example, this is actually, the name of this triangle is triangle ABC because of these letters out here. And so this side right here is actually called side BC because it is the side between the letter B and the letter C. Another way to represent that is to write the letters BC and then put a line above it like that. That represents side BC. So we know that side BC is 16, and we want to know what side AB equals. So we want to know what AB equals. That's what we're trying to figure out. That's what our X is. Well, if this side is 16 and it is supposed to be equal to where X is, we know that X would also need to be 16. So side AB would also be 16. We can use this information to find missing sides because we know that those two sides with those little tick marks are supposed to be equal. Another triangle that this works for are equilateral triangles. In an equilateral triangle, we know that all of the sides have tick marks, meaning all of the sides are equal. So if side DE here equals 5, that also means that this X down here would also equal 5. And that even this side over here would be 5. So every side of this triangle, and by the way, the name of this triangle is DEF, and every side of this triangle, whether it be side DF down here or side EF here, they all would equal 5 because in equilateral triangle, all sides are equal. So again, we can use that information to find a missing side or a piece of a missing side. So let's go ahead and take a look at a couple examples of that. So here in number 1, I see two tick marks. That tells me that I have an isosceles triangle, which means that if this side right here is 20, that this side also is supposed to equal 20. And that actually gives me an equation I can solve. X plus 3 is supposed to equal 20. Well, since I have that equation, I know how to solve that equation. How do I undo what's happening to X? Well, I subtract 3 from both sides. These are going to go away, leaving me X, and 20 minus 3 is 17. So that tells me that the X right here needs to be a 17 because 17 plus 3 would give me that 20 that I need in order to make those two sides equal. So X equals 17 is the missing part of that side. Over here on number 2, we have an equilateral triangle. How do I know that? Well, because I see that there are tick marks on every side of the triangle, indicating that every side of the triangle has the same side length, and that side length is 14. So, this side is 14, this side's supposed to be 14, and this down here where we have this 2y, it's supposed to equal 14 as well. When we write that, we actually have an equation to solve. What's happening to y? Well, it is being multiplied by 2, so to undo that, I divide by 2 on both sides. These 2's are going to go away, leaving me y, and 14 divided by 2 is 7. So the missing piece of that side that I need is a 7. So this y right here should be a 7 because 2 times 7 will give me that 14 that I need to make it equal to all the other sides. So those two little fun facts about isosceles triangles, how they have the two equal sides, and equilateral triangles, how they have 3 equal sides, can actually help you find missing pieces of the sides of the triangles. I hope this helps kind of explain any confusion you may have about the side relationships in triangles, and I'll talk to you later. Bye!